From the previous page that we had, we were able to identify that both of these functions are inverses of each other. And I want you to understand what that means when you look at their graph, or look at their graphs, actually. Okay? So the thing you'll understand here, and you'll see, when we compare f of x to its inverse, g of x, and again, we talked about how g of x, if this is the inverse, we'll use that notation, so f inverse of x. If you have an ordered pair a, b on your function, on the inverse, you'll have the ordered pair b, a. So it's the same coordinates, it's just flipped around. And this goes back to our discussion from the other day, where when we talk about the cubing function, if you plug 2 into the cubing function, what do you get? Yeah? You plug in 2, you get 8, right? But the inverse says if you plug in 8, you'd go back to the original, which is 2. Because remember, the inverse is trying to go back. It's, like I've mentioned, reverse engineering, it's like code breaking, right? If you have a code that maps numbers to letters, you need to be able to break the code and have the decipher, or have the cipher to break it, which means you would take the letters going back to the numbers, right? And that way you can decode the message. Maybe you did that when you were growing up. You wanted to send secret messages to your friend, so you made up your own little alphabet. Or maybe that was just me, because you were bored in 8th grade, and you were just excited that you had a friend.
I had a book. I made a book.
A book?
Yes, I made multiple codes in a book, and my whole family used them.
Oh.
We had 3 different releases.
Well, that's better than what I had, because only one other person knew the code. And it's really funny when you go back and you look in your yearbook, and like, oh, there's the message that my friend left me in 8th grade.
My mom and I have our own language.
Great, I know, you speak Spanish. You're amazing, you're bilingual.
Oh my gosh, it's not even that. We removed the vowels with eyes. So we replaced the vowels with eyes. So for example, like, I don't know what to say.
So if you wanted to talk about the word ability, you would just say ability.
No, it only works. I'm pretty good at Spanish. It only works in Spanish, okay?
Oh, it only works in Spanish.
Yeah.
Ah, see? So, okay, you have a secret code in Spanish. Well, here's what I want you to do. Now, this is not quite as cool as the secret codes that you have, the books, the languages. I want you to look at the graphs, all right? So in blue, I know, what a transition. If I look at this guy right here, his y-intercept is going to be 0, 4, and he has a slope of 2, so I'm just going to go ahead and plot using this. I hope I don't make a mistake, especially since I'm recording this. But I'm sure that I will make a mistake. That way everybody can see it and make fun of me. And make sure you go to the comment section below to talk about how much you think this sucks and how horrible I am, because you're an internet troll.
I don't think you're a good commentator.
Wait, are you actually recording today?
I am recording, yes, and now you're recording too. So now you got to get your SAG card. So this is what the blue guy looks like. Let's go to the pink guy, who starts down here at 0, -2. You're going up 1 over 2. Love that slope. And come down here. Make sure that you know how to count. You're just going 1 and 2. Hopefully you can count that high. I'm sure you can. You guys are amazing. That's right. That's right. You are. So I want you to look at these graphs. Now notice what I graphed here, this dashed line. This is y equals x. This is the identity function. And what you'll see is that this blue line, if you could copy it on the other side of the identity function, gives you the pink line. That's what the pictures are going to look like. So when you go into the homework and it says graph a function and its inverse, you're going to be looking for how they are reflected across y equals x. So, for example, this, I said AB becomes BA. This ordered pair right here is the ordered pair 1, 6, which means on the inverse, you should have what ordered pair? You should have the ordered pair 6, 1, and lo and behold, there it is. Is that amazing? Of course it is. This ordered pair right here is the ordered pair -5 and -6. So what should be on the inverse? -6, -5. Right? Just like that.
Will the inverse of a function always hit it at that same kind of, I mean, I guess just depending on what the function is, the inverse will, because they intersect at one point.
Well, here's the thing. They could intersect at many points, But what you're going to find out is that, I'm sure I'm going to mess that up, the intersection points should be happening on y equals x.
Okay. Why? Why would they only occur on your parent?
Well, I'm sure that may not always be the case. There might be other points of intersection. You know what? There could be other points of intersection, but you're going to find out that if one touches y equals x, the other one's going to have to cross there as well.
That makes sense because you're reflecting over it, and so.
Yeah, and so now I'm trying to think. You know, I need to play around with it because I hadn't really thought about it. Could they intersect somewhere else? I want to say that intersection points. You know what? I got to think about that. I'm sure someone's going to say something in the comments that I don't read about that. What? Oh, I could crop that conversation out. I should do that. This never happened. So the domain for your function ends up being the same as the range for your inverse. Likewise, your range for your function is going to match up with the domain for your inverse. The big thing to understand here is that x becomes y and y becomes x. If we can remember that, we shouldn't have any problems. If you have an x-intercept, I'm not saying you will have an x-intercept, but if you do, if it's of the form a0, what would an x-intercept give you for the inverse? Take a wild guess.
Well, 0, it'll give you the y-intercept.
It'll give you a y-intercept at the ordered pair 0a, because you would just take those ordered pairs and flip them around because you're talking about the inverse. Likewise, a y-intercept that could be at the ordered pair 0, comma b. A y-intercept on a function will give you what for the inverse? It'll give you the x-intercept. And again, you flip the ordered pair around. Connecting back to the rational functions we were discussing in the last section, if you have a horizontal asymptote, horizontal asymptotes take on the form y equals, again, b. I'm not saying that these are the same b values, I'm just saying if you have something that's of this form, a horizontal asymptote would correspond to what for your inverse? It's going to give you a vertical asymptote where x is now equal to that value. Things are getting all topsy-turvy here. X becomes y, y becomes x. So if you have a vertical asymptote for a function, let's call that x equals a, then what would that give you for its inverse? It'll be a horizontal asymptote at y is equal to that value. Okay? So that's how it's going to go. What do you guys think? Now suppose I give you a graph. So next I'm going to give you a picture, I'm going to give you a graph, and you're going to tell me, you're going to give me a picture for its inverse.
Let's do it.
Oh, most deaf. And true that.
I'll get you some comments.
Almost anything I do is going to give me comments. I'm really surprised my children haven't gone onto my YouTube channel just to throw kinds of shade my way. So I'm going to give you this function. I'm going to say f of x is equal to the cube root of x plus 2. What's the shape for the cube root of x?
Cube root is that weird.
Weird. Wow, that's
Well,
really rude.
Okay, so it comes and then when it goes through the origin,
Yep.
it doesn't, like it has a, I forget what you call that.
It's kind of like a cactus that's been blown over, right? Sideways cactus. A snake. No, you're not going to do your arms like that. You're going to kind of, it's walk like an Egyptian. Not that Egyptians walk like that, but yeah, thank you for popularizing. Now, but how have you shifted that snake guy? What does the plus 2 mean?
Up to.
It means up 2. So I'm going to start here, and then I'm going to put my nice key points I would have had for the cube root function, which means I would have 1 gives me 1. What's the next value you would have plugged in for your cube root function?
8, which gives you 2.
So 8, I'm going to go up 2, and then I'm going to come back over here and put my other points. So this is the cube root of x plus 2. Okay? If I want to find the inverse, I need to make sure that I copy things back to the other side of the identity function y equals x. So if you had identified some of these key points here, like this is the ordered pair 8, 4. So what would you have for the inverse?
4. Oh, for the inverse?
Yeah. What point would you have on the inverse?
4.
4, 8. X becomes y, y becomes x. You just kind of flip those guys around. So 4, 8 would be a point. I see I have this guy right here, which is the ordered pair 1, 3. So what do you have for the inverse?
For the inverse,
Oops.
3, 8.
For the inverse, you would have the ordered pair 3, 1. This main point right here, this is actually a point of inflection, is 0, 2. So what would you have, or where would that point be located on the inverse?
2, 0.
2, 0. Again, you just flip those coordinates around, so you'd have 2, 0. If I keep going here, this is negative 1, 1. So I should have 1, negative 1. Then back over here, I have the ordered pair negative 8, 0. And that point corresponds to what on the inverse?
0, negative.
0, negative 8, right here. Now, what's the shape that I expect to be connected to the cube root function for its inverse? The cubing function, right? And so when you connect these dots, you see that that's exactly what we have. From this picture, from what you graphed, can you identify what the function notation would be for this inverse?
Function notation.
Yeah, so what would the function notation look like for this pink graph that I have here? It's going to have a cube.
On the x, the leading coefficient is going to, or like the front x is going to be cubed.
So I'm just going to write x to the third?
No, because you have translation and everything as well.
So how would I express a cubing function that's been shifted to the right 2 units?
Just add 2 again.
Minus.
Or-
Say it.
oh, no.
You're right. It's going to be x minus 2, and then to the third power. Remember, you're sliding to the left or the right, which means the adjustment's going to be made on the inside. And that's what gives you this. Now, I want you to notice some things here. What would undo a cube root?
Cubing.
Cubing. What will undo plus 2? A minus 2. But the order is going to be very important so that we have it undoing things in the correct order. And that's what we're going to talk about next.